Welcome to Spring LIB.
So this question is asking you to calculate the value for delta G using the values of delta H and S for the following reactions: Pb, 2Pb plus O2 gas, solid plus O2 gas, formed 2PbO. So we're going to first calculate delta H of the reaction. You need to use the appendix L from the back of your textbook. And delta H is calculated by using the sum of the heat of formation of your products minus the heat of formation of your reactants. So what's nice about this one, both of your reactants are elements. Elements have no heat of formation, so we know that that is going to be 0. So we just got to worry about the heat of formation of our products here. So it's only one product, so we have to worry about twice the amount of energy of our heat of formation of our product. So the delta H of your reaction is going to be equal to 2 times the value for lead 2 oxide, which is negative 219 kilojoules per mole. So that comes out to be negative 438 kilojoules per mole reaction. So now we have to calculate the delta S of the reaction, which unfortunately, in this case, everything has a delta S because we measured from 0 Kelvin, and this is measured at 295 K. So that we use the sum of the enthalpy of your products minus the sum of the entropy of your reactants. So for this one, your products are 2 times 66.5 joules per mole Kelvin, and then we subtract 2 times 64.81 joules per mole Kelvin, added to 1 times 205.07 joule per mole Kelvin, and we get that the delta S of the reaction comes out to be negative 201.69 joule per mole times Kelvin. So I have to use these two values together to calculate delta G of the reaction. So delta G equals delta H minus T delta S. The T in this case is 298 K, so the 25 degrees Celsius. So delta G equals negative 438 kilojoules minus 298 Kelvin times, we have to convert this delta S into kilojoules, so we divide by 1,000, so it's 0.20169 kilojoules per mole times Kelvin. And we get that the delta G of the reaction equals negative 377.90 kilojoules per mole reaction. Now the question is this enthalpy or entropy driven? So we have to look at the signs for enthalpy and entropy. So in this case, your enthalpy is negative and your entropy is negative. This would indicate that this is enthalpy driven. You want to have positive entropy and negative enthalpy to be driven by both. Well, since we only have negative enthalpy, this is said to be enthalpy driven. So we repeat the process for the second reaction. We get that the delta H for the reaction itself is negative 86.61 kilojoules per mole. That's negative. We get the delta S of the reaction is positive 213.43 joules per mole Kelvin. We plug it into the delta H equation, and we get that the delta G equation rather, the delta G is negative 150.21. This is another product favored reaction. And now that the delta H is negative and delta S is positive, this is driven by both enthalpy and entropy.